Welcome to Fun with Drilling Engineering. This is a downhole drilling motor. It works in this way. Drilling mud is pumped in at the top, and as the mud flows, the drill bit below the motor starts to spin. The faster the bit rotates, the higher the penetration rate. So where exactly does the power for such a downhole motor come from? The power section of the motor comprises of a stator and a rotor. The rotor and the stator fit together in such a way that the different shapes of both components create small chambers that are separated and sealed from each other. The drilling mud is pressed into this chamber at the top, and the only way for the drilling mud to move along is to set the rotor in motion. The cool thing about all this is we can make different shapes for the rotor and stator to give the motor a specific characteristics. For example, I have here a completely different rotor and stator configuration, and behind me you can also see downhole motors can be manufactured in many other shapes. Each of these configurations rotates at a different speed and has a different torque output. In any case, in a specific cross-section of the motor, each chamber is filled with drilling mud of a different pressure. And to maintain the differential pressure between two neighboring chambers, an effective seal is required between them. That is why we have rubber in the stator tube. The rubber ensures that the chambers are sealed against each other. If the fit between the rotor and the stator is too loose, then mud can flow from high pressure chamber to a lower pressure chamber, causing the motor to lose power and get weak. On the other hand, if the fit is too tight, then the rotor is working too hard on the rubber and creates excess heat that can destroy the rubber and lead to a motor failure. The secret of a good downhole motor lies in the optimum contour of the rubber so that it fits exactly right with the motor. The shaping of the motor is further complicated by the fact that some of the ingredients in the drilling mud will react with most rubbers. It is just like with the Gummi beers here. If you dip them in different liquids, you can see here, the Gummi beers will swell to different degrees and lose their hardness. That's how it is with the rubber in the power section of a downhole motor. That is why we always try to install as little rubber as possible in such a motor. In fact, some time ago, engineers managed to develop a design where the inner metal surface of the stator tube is shaped in a way that only a very thin layer of elastomer needs to be applied in the stator. Such a stator is quite difficult to manufacture, but since there is much less rubber involved, there is less reaction with the drilling mud. Of course, you can ask, can we perhaps even build a motor without any rubber parts at all? In fact, there are such metal-to-metal motors. The rotor and the stator can rotate with a very precise fit into each other. Such motors already exist, but they can only be applied under special working conditions. As there is no rubber between the rotor and the stator, every small stone, every small chunk that goes into the power section can cause damage to the parts. So in most cases, we still need rubber in the downhole motors. But research is still ongoing about this. This and everything else about downhole motors you can learn in our lecture here, Basics of Drilling Engineering, here in Freiberg. We look forward to seeing you. Look off.